Okay, your studio again, Professor Dr. Dolphy Gilpin, and we are on random uh, selection of the elements here and with introductory properties and uh, notes. And so we have chosen now atomic number 23, so let's find 23, which is vanadium, 16, 17, 33. So it might be over on this side. So let's switch over here. We're looking for atomic number 23, 1749. 25, 26, 27, 28. So it's not here. So let's try this one. 23, vanadium. So there we have vanadium. Let's highlight it a little bit here. Atomic number 23 is in group 5. Atomic weight of 50.94. There it is, vanadium. Beneath it is NB. That's probably niobium. But let's see. 23, vanadium. Group 5, and beside group 6, next to it would be chromium, and next to it on the left would be titanium. Okay. So we have an introduction to vanadium here with atomic number 23. And let's see if we could, this is gallium, nickel. Let's see if we could get V, vanadium here from our cars. Cadmium, nitrogen, helium. The cards are random, so it makes it a little bit awkward to separate it. Here, helium, silver, mercury, chlorine, iodine, magnesium, lithium. Because it's here. Bismuth, lithium, indium, radon, radium, oxygen, hydrogen again, phosphorus, carbon, lead. You're looking for vanadium. cesium, polonium, plutonium, samarium, tellurium, flugium, acetine, selenium, iridium, yttrium, uranium, yttrium, hafnium, curium, francium, mendelevium, cadmium, livermium, barium, francium. It's one of the rarest elements there, francium. Radon, titanium. Where is vanadium? Carbon, molybdenum, americium, europium, cerium, vanadium. Here we go. Dig deep in this random deck here to extract vanadium from 118. And actually these are 118 because sometimes we have a redundancy with those that, like oxygen, we have 3 O in it to represent the molecule, the atom, and the ozone. And nitrogen, we probably have 2. But anyway, vanadium, atomic number 23, atomic mass 50.942, or atomic weight, which is the average weight of the isotopes, taking in consideration their abundance in nature, and we come up with a 50.942 for the atomic weight. And little introductory notes, we have that it's a transition metal, solid at room temperature, in the 5th group and the D block. And we have shown that there already. Then you have that the vanadium alloys are used in nuclear reactors. That's the alloys. And the oxides are used as pigments in ceramic tiles and glasses, and as a catalyst, and in production of superconductive magnets. That's what the vanadium is used in, the production of superconducting magnets. It's essential, including humans, although humans need very little vanadium. The abundance of vanadium in the Earth's crust is compared with copper, nickel, and zinc. However, it is most expensive. As we continue with vanadium, to recover vanadium using steel alloys and space vehicles and nuclear reactors, aircraft carriers, vanadium steel alloys are perfectly suited for tools, pistons, axles, rods and girders. That's the uses of the vanadium and the vanadium alloys. Vanadium was also discovered twice. In 1801 by a professor of Mexico in Mexico City called Andres Manuel del Rio. It is discovered twice. One of the discoveries was in 1801 by a professor in Mexico City called Andres Manuel del Rio. Okay, you have some notes on vanadium. Vanadium is not toxic in small amounts, but when breathing and vanadium oxide, dust and powder, it can cause damage. So the dust and powder when breathing can cause damage, but in general, in small quantities, it's not toxic. And further exposure, long exposure to dust and the powder inhalation can cause lungs damage as well as stomach. Damage the lungs and the stomach. We can find vanadium in China and Russia, South Africa. An isotope of vanadium, we have V30, V50, 24% abundance, and V51, 99.7076% abundance. And vanadium is slightly radioactive. In a transition metal there. Slightly radioactive, having half-life of about 3.9 multiplied by 10 to the 17 years. Food high in vanadium, we have cabbage, mushrooms, parsley, chili, radish, spinach, black pepper, green beans, carrots, and oysters. Vanadium is found in US in the US. It is found in the mountains of the Arkansas, the potash sulfur springs called the Wilson Spring Complex, and also in the Garland country. In the Margaret Cove complex. That's where you'd find the vanadium in the United States, in Arkansas Mountain, in the Wilson complex or the Wilson Spring complex, called the Potash Sulfur Springs. And the Magnet Cove complex, also in the Hot Spring country, Hot Spring County. As you know, vanadium is paramagnetic. Its abundance in the earth crust is about 50 parts per million, and the cost is like $19,000 to $19,900 per pound. And too much vanadium in the body results in diarrhea, weight loss, and vomiting. Also have some hepatic and nephrotoxic effects, impact on the body with too much vanadium. Hepatic and nephrotoxic, hepatotoxic and nephrotoxic impact on the body. That's too much vanadium. That's introduction to vanadium, and you want to look at the reactions and so on at a later time. Vanadium 23, 50.942.